Hello, everybody. Welcome to my talk. My name is Peter McKee. I'm on the developer relations team here at Docker, and you can follow me at pmckee on Twitter. Today, I'm going to be talking about how to get started with Docker. So we're going to start out today talking about containers and why we care. And then we'll look at installing Docker on your local development machine. And then we'll write some Docker files and build some images. And then we'll run those images and manage images. And then we'll ship those images up to the cloud. And then we'll wrap up by taking a look at Docker Compose for local development. So why Docker? Well, there's a problem right now. We have a lot of individual machines, VMs running with OSs running in those, whether it's on bare metal or inside of a VM. And these operating systems are hard to maintain. They're hard to keep up to date. You have to patch them with security patches. You have to install all the dependencies. And you have to upgrade the operating system. And then you have to install your application code on it and configure that. I used to work at a large computer manufacturing company here in Austin. I won't mention the name, but we had hundreds of servers in our data center just for the e-commerce platform that I worked on. And you can see here on the screen that we had over 100 servers just for our browse and our www layer, 50 in each data center, 100 for being able to configure your purchases. So when you would go onto the www layer and find a laptop that you liked, and then you would choose it, and then you could configure it, add memory to it, and those type of things. So we had hundreds of servers there, 50 plus in each data center. And those are just two of the services we had. We had multiples, right? And these machines were very hard to keep up to date. We had scripts that we would run to update these and deploy application code, to install security patches. But we had to keep a list of the servers in a file, and sometimes that list wasn't always kept up to date. Someone would fat finger a server. So this led, not all the machines would get updated, right, when we tried to update them, even with application code or a security patch. And this led to intermittent errors. So a user would come to the website, they would see a laptop that they liked, and they would choose that, and that request would go to a server. Well, if that request hit a bad server, they would get an error. And so what the user would usually do is just hit refresh, and that request would go to another server, and that server could have been fine. And from there on out, they could have hit all normal servers the whole way out. And we would get these errors, and it was because one of the 50 servers in the data center wasn't configured correctly. And so to try and troubleshoot this was a nightmare. You had to look at multiple layers. So we really thought of our servers as pets. We wanted them to stay up and running for long times, 5 nines uptime. And when one went down, we'd pull it out of the layer. We'd try and fix it and heal it and put it back into the layer. And it was just really hard. Well, Docker has a solution to that, and containers are a solution. And so what if we could take our application, its OS, all of its dependencies, its configuration dependencies, and bundle that all up, right? And let's call that an image. So you're able to take that image, deploy it out onto a server. You could deploy multiple images on those servers. And then if one of them goes down or two of them goes down, you just put a new image out there and the application's back up and running. No longer do you have to pull that server out of the system, try and fix it and patch it. You just deployed a new image to it. And these are all copies of each other. So you don't have to individually configure each one of those applications running on those servers. And then we can look at our servers and our applications as ephemeral, short-lived. So if they died or went away, that's okay. We just replace them. Docker really focuses on 3 kind of phases in this new world. So we focus on building images, shipping images, and running images. So if you could build your image and consistently package everything up into one image, then you could easily ship that image anywhere you wanted it. And this allows you to, you could ship it to a local developer, another developer that's on your team, and they can easily run that image, right? Consistently run that image. And this leads to all the things you see nowadays. So CI/CD, continuous integration, continuous deployment, being able to run your applications easily and test them through a production stage, UAT, all those type of things. You can run different versions of your application locally. You can run different applications of vendor software. So sometimes I run a different version of Mongo side by side. And it allows you to do things like rolling forward, like I was talking about before. So when your application goes down or you find a defect in your application, a developer is able to fix it, and then through its CI/CD pipeline, just deploy that new fix, and you don't have to pull it back down, try and fix the code in live in production or anything. And the easiest way to get started with Docker is to download Docker for Desktop. And you can find that. You can see the URL here on the screen. You just go to that website, choose whether you want Mac or Windows and download it and follow the install steps. It's very simple to get started. Okay, so let's jump over and take a look at some code. What we're looking at here is a Docker file. So a Docker file is used to build your image. So you can think of a Docker file as just a list of commands that get sent to the Docker engine. And the Docker engine starts at the top and reads down through those, executing each one in turn, and builds your image. So the first command we're going to give Docker is from. And when you build images, you usually start out with a base image. These are verified images that live up on hub.docker.com. And you can start with a base image that has everything you already need in it. So this application that we're taking a look at here is a Node application. So I'm going to use the Node base image. So it already has Node installed in it. It has NPM installed in it. It has Yarn installed in it if you're going to use that. And so we tell Docker, start with that Node image, and then we're going to build on top of it. And so the first command we give it is the from. And we say from Node, 12.16.3. 12.16.3 is the tag of the Node image we want to use. 12.16.3 is the latest long-term supported version. And so the from command tells Docker, use this Node version, this image, and we're going to build on top of it. Then we use the working directory. So what the working directory command tells Docker to create this directory /code and use that as our working directory. So all subsequent commands will use that directory. And then on line 5 here, we set up an environment and variable with the env, and we name that variable port, and we assign it 80. And so environment variables will then be able to be accessed by any processes that are running inside of your image. And then on line 7 here, we copy in our package.json file. We copy that into the image, and we put it into code package.json. Package.json tells Node what modules we want to use, what our application requirements are. And then we use the run command. So everything after the run command, Docker will execute. So it's going to run npm install inside of the image. And npm is the Node package manager. Node package manager will use package.json. Look inside there for a list of dependencies. We'll download those and put those into the image. And then on line 11 here, we copy everything that's in our working directory in the local directory denoted by the dot. It's going to copy all of that and put it inside the image in the code directory. There's also this file that you can have on your local machine. It's called a Docker ignore file. If you use a Docker ignore file, it's very, very similar to your get ignore. And you just list out what folders you don't want to be included in your image. So copy will take everything, and I'm using the dot to say in the current directory, take all that and put it into my image. And then on line 13 here, we use the command. The command is used to give the engine the default command that it should run when it starts our container. So when you tell Docker to run your image as a container, Docker looks at the command and says, oh, okay, I'm going to run Node, and I'm going to pass in the Node the source server.js, and that's the application, that's the command it's going to give to our image to run. Okay, so we started at the beginning. We used a base image called Node. We set up our working directory. We created an environment variable named port. We copied in our package.json, all of our application dependencies. Then we ran an npm install to install those dependencies into the image. And then we copied all of our source code into the code directory. And then we told Docker, call Node and pass it in server.js when you start this image. So let's jump over the command line. Let's build our image. So the way you build an image is there's a Docker build. And I'm going to do run the help so we can see what options you could pass into it. So if you look at it, I want to look at two options real quickly. We have the tag option. And so that's how you name and then optionally give it a tag. And it needs to be into this format. So name : tag. So if we look back at our Docker file, that's what Node did with their image. They said Node : 12.16.3. Right? So we could do the same for our image. And then the second flag here is the file, -- file. And that tells you where the Docker file is located. The default is just whatever the path you give to it. It'll look for the name of Docker file with a capital D. So you can see here we can do Docker build, pass in options, and then we give it a path. So let's go ahead and do that real quick. So we're going to run Docker build -- tag. I'm going to call it hello-world. The path is just going to give that current working directory. Let me show you. Here in our working directory, you can see that we have our Docker file. Okay. So let me do Docker build -- tag. I'm going to give it hello world, and then I'm going to give the path as the local directory. So let's run that. So you can see here what Docker's doing is it pulls in our Docker file and starts executing the commands. Right here you can see step 1 of 5, and then 2, 3, and on and down. You can see the from command, the working directory, the copy, and so forth and so on. So it runs all those commands, and then it writes our image and gives it a SHA, and then it'll name our image as hello world. So let's clear the screen real quick. Now to see a list of images that you have on your local machine, you could do a Docker images. So there we go. Here's a list of images I have on my machine. You can see the hello world image that we just built. All right, okay, so next thing, we had our Docker file, which we told Docker how to build our image. We did a Docker build, built our image, and you could see it, we just looked at it. Now we want to run that image. And so Docker has a run command. So do Docker run. I'm going to do -- help so we can take a look at it. Now the run command has a bunch of options you can send into it. You can do things like run it detached. You can set CPU limits. You can tell what DNS to use, all kinds of different things. For right now, we're really just going to run, very basically run our image. So we run Docker run, and then you just give it the name of the image you want to run. So I'm going to run Docker run hello world. So we run it, and now we're listening on port 80. Let's go over to our handy dandy browser here, and let me refresh. Oh no, nothing's coming up. That's because your containers are run in isolation. So basically, a container is just a process that's isolated from the rest of the system. It has its own file system. It has its own network. It's restricted to CPU and memory usage. And so we didn't give it any ports. We didn't map out any ports. We didn't connect it to a network. So when in the browser, when we try and connect to it, we're not able to connect. So let's do that. So let's give it, real quick, I want to show you. So right now we have, let's look at what's running. So to see if anything is running on your system, you could do a Docker PS, that'll call processes, PS for processes. And we don't see anything running. But if you do a -A, that will show you everything. And we could see our image that we had run above here in this run command. We could see the image hello world. Here's the container ID, SHA. And it said it exited about a minute ago. And it gave it this name of crazy Patalomi. If you don't name your images, Docker will name them for you. And so we can see we still have that same image there. So let's remove that image. Well, before I do that, you can also start your Docker images. So let's do Docker start. Just give it the name of the image. And it's back up and running. Let's do a Docker PS. And there we can see that it's running up 5 seconds ago. So let's stop it. So you could do a Docker stop and now do a Docker PS again. And we see that it stopped. And if we do a Docker PS -A, we can still see it's there. So let's remove that image now. Let me clear the screen. So we do a Docker remove and give it the name of the image. So now if we do a Docker PS, we won't see it because it's not running. And then we'll do a Docker PS -A and we can see it's been totally removed. Okay, so let's take a look at our images. So again, to see what images are local, you do a Docker images. So now, remember when I first started it, we weren't able to connect to it in the browser because we didn't allow our container to have any access from the internet. I'm going to expose a port. So I'm going to do a Docker run. And I'm going to do -P. I'm going to give it 8080:80. So I'm going to map port 8080 on the local machine to port 80 inside of the container. And then I'm also going to name it because I don't want Docker just to give it a random name. So let's call it hello. You can run your container in the background detached. So for long-running processes, such as Node, a web server, we just want it to run in the background as detached. So we can give it a -D. That'll run it as detached. And then we'll give it the name of the image. And so now we're running. When you do a -D, Docker will spit out the container SHA, the container ID. So to see our container running, we do Docker PS. There it is running. You can see the name is hello. And now you can see that we mapped port 8080 into port 80 in the container. So let's go over here to the browser and let's put in port 8080. And there we go. We can see it running. Now we can stop that. Do a Docker stop. Hello. Okay, it's stopped. Now we don't see it. And we do a Docker PS to show us our running processes. It's not there, but if we do a -a, there it is. And again, you could start that container back up, do a Docker start, and we'll just give it hello. And now it's back up and running. And that's how you start and stop your containers. That's how you build images. That's how to connect a port into your image, how to run it in the background. So now that we have it running, what if you run your container in the background and you want to see what logs it's producing? So Docker has a command, Docker logs, and just give it the name of the container. And you can see there, it's listening on port 80. We stopped the server, and then it's listening on port 80 again. You can also run a -f on the logs. So let's look at the help here real quick. And you can see a -f or -- follow. So that allows you to follow the log. So if you're running an image locally and you're having a problem with it, you can attach and follow the logs and see all your logs coming out. So let's do that. -f and then give it the name of the container. And now you'll see it's listening. This application, we're not dumping anything out to the logs. But to get out of watching the logs, you just hit a Control-C. But that did not stop our container. Our container is still running. So let's stop our container. Hello, and then Docker ps-a. We can see it's still there. Let's remove that container. So we Docker remove hello. Now we should not have it running. Cool. But we still have our image. So we looked at building an image and running an image. Now let's look at how we can share that image by pushing it up into Hub. So let's go back to our browser and let's take a look at Hub. So Docker Hub is where all your base images can live. It's a repository for images. And it has some auto build capabilities. It has some CI/CD capabilities. It has some organizations and teams where you can set up RBAC, rules-based access control for your teams to give them access to your images. So you need a Docker ID. So you log into hub.docker.com. If you don't have a Docker ID, you can sign up right here. Of course, I already have one. So let me go ahead and sign in. Okay, so I'm signed in. This is the dashboard. We see I have 3 repos already. So I'm going to create another repository so we can push our image up into the cloud. So let me create a repo. I'm going to give it the name of Hello World. And you can give it a description if you like. And then you can mark your repos as public or private. You could do auto builds. So if you're connected to GitHub or Bitbucket, every time you push, you can set up a hub to listen to that, and it'll build your tests for you. It'll run your tests and build your images for you, and then push it into the repo. Okay, so we named it Hello World. Let's create it. Okay, so now we have a repository where we can push our image. And you can see up here, there's a tags, and we don't have any tags yet. We don't have any images pushed. Let's go back to general. If you look over here to the right, you can see this Docker push command. And so this is the command we're going to use to push our image up to Hub. So now we'll come back to the command line. And let's look at a list of our images right now. You can see the name is Hello World latest. Name of the image needs to have the repo name, pMcKee Hello World, and then give it a tag. So if I run this command right now that I took out of Hub, so if you look here, here's the command, right? If I tried to run that now, it's going to say, I don't know what image that is, pMcKee, right? So what we need to do is we need to tag our Hello World image with pMcKee. So we'll run the Docker tag command, and we'll give Hello World. We'll give it pMcKee Hello World, right? So now if we look at our Docker images, now we have 2 images here. So you can see we have Hello World and then pMcKee Hello World. And so now we can just push that image up into Hub. If you remember back in Hub, this is the command right here. So we're going to do a Docker push. I'm going to tell it pMcKee / Hello World. And now it's going to push that up there. It's pushing all the layers up. Hopefully my internet connection does well, it goes fast. It usually is. You can see now right here that these layers have already been mounted. That means that they're already up in Hub. And so Docker kind of looked at it, Hub looked at it and said, oh, we know what this layer is. Don't worry about sending it to us. We already have the node base image up here. And we're almost done with the last one here. Okay. There we go. Okay. Now if we take a look at our tags, there we go. Now we have the latest tag and was just pushed up a few minutes ago. So now we could take that, we could plug that into our CI/CD, and we could push that into Stage. We could push that out into AWS, into Google Cloud, into Azure, all different kinds of places. Or you could even set up an image locally that you need to share with a coworker, and you can push that up to Hub and they just pull it back down. Let me show you how to pull. So let me clear my screen. So I'm going to go Docker Images. I'm going to remove that McKee Hello World. So I'm going to do Docker RMI to remove the image, and then Hello World. So now it's gone. So let's do Docker Images. Let's do a Docker pull. McKee Hello World. It's using the default tag latest. There we go. It took a look at it and said download the newest. So let's do Docker Images. And there we go. We just pulled that image back down. Excellent. Okay, so we took a look at how you build an image using the Docker file, how you set up what you want to get put into your Docker file. We built that image. We took a look at it locally. We ran that image. We exposed some ports. We ran it detached. We looked at logs. We started and stopped and restarted images. And then we pushed them up into the cloud. Now what I want to do is show you how you can take a lot of that and you can run it in using Docker Compose. You can set up your development space to run all these services. So let's say we only have one application here right now, but let's say we're working in a microservices shop, or you just had multiple applications you need to run, or you had a database you needed to run alongside your application. Starting and stopping each one of these containers all the time can get a little bit tedious. Docker has another tool called Docker Compose. What that does is it composes a lot of files together. So if you take a look at this compose file, I have one service, I have the web service, and underneath this build section, I tell it the context, just like the path that we did when we did a Docker build on the command line. I tell it the name of the Docker file, and then I say name the container web, and then expose port 8080 and map that into port 80 inside of the running container. Now what I can do is I can come over here back onto the command line. Let's clear. And you'll see I have this Docker Compose file right here in the root of my file. So I could do a Docker Compose, and I could say, and I'm going to give it a -d so it'll run in the background. And what it's going to do is it's going to look and say, okay, I don't have any images named web, so I'm going to go ahead and build that. So now it's running down, building everything, running npm install. It'll take a couple minutes. It's pulling down, taking all your npm packages and pulling them down and putting them inside the image. We're almost done here. Now it's copying the source code in, and there we go. Let's clear here. Docker Images. We can see here this web. So what Docker Compose does is it looks at your current directory, so docker-hello-world. All the images that you're building from that Docker Compose file, it prepends the name of the directory, does an underscore, and then the name of the service. So our name of our service is web. So it took Docker hello world underscore web and created it there. Now remember I did a -d, so let's go see if it's running. And we can see our image is running. It gave it the name of web. Back in our compose file, we told it name the container web, and it was up 52 seconds ago. And we mapped port 8080 into port 80 inside the container. Now if we come back here, let me change the ports. Okay, now let's try port 8080. Whoop, got to type it right. And there we go. Hello, Docker. So now to stop your application, we can do a Docker Compose down. That'll stop the web and removed it. If we do a Docker PS, it's not there. If we do a Docker PS-A, it's also been removed. All right, so that's great. We're running our one container. But let's say we had a database, right? So let's go over here. I have another little bit for our database. So I'm just going to paste that over top. So you can see at the top, I still have my services, the web, building the context, same as before. And now I have another service called DB. I'm giving it the image of Mongo 3.6.1, giving it a specific tag. You normally want to give everything a specific tag. And then it says name the container DB, and then I want you to map some volumes. Volumes in Docker is the way we do persistent storage.
And so I'm going to say, I want you to create 2 volumes for me. They're named volumes. So MongoDB, and I want you to map that inside of my container to whack data, whack DB. If you know anything about Mongo, that's the default area where Mongo will store all your files. And then we're going to expose our ports. And then the command we want you to run is mongod. And then down here at the bottom, we define those 2 volumes. And we're just giving them named volumes. Docker will manage the volumes, the storage, everything for us. So let's save that. Let's come back over here, and we're going to do a Docker compose. And we're going to do an up-d again. And you can see Docker's going out. Oh, yeah, Mongo, let me go pull that image down for you. And there we go. Let's see, Docker PS. And now we have our same web app image running. And then now we have Mongo running. So now we could run Robo, which is a little GUI client that connects to Mongo. So let's connect to localhost. You'll see as localhost 27017. Let's go back, look here, see how it mapped the ports. Let me connect. And there's my hello world database. And we have all of our connections. All the data is stored. We just spun up a whole Mongo database with just a simple container. Now, you can see how if you had a bunch of services, microservices, even just your front end, your back end in a database. So easy to spin these up. They're all on the same network. They can all connect to each other. And then you're able to share those images out and share this compose out with your fellow developers. They just run your compose file and they have your whole code running, no problem. So we covered a lot. We started looking at the problem of why Docker. What does Docker solve? How does it solve it? We talked about we needed to really compose and package up our application and all its resources, the OS files, everything it needs to run. And we did that by doing Docker build. And then we want to be able to run that nice and easily and consistently as many places as we want. And so we did that with Docker run. And then we want to be able to ship and share those images across the internet into our production and stage environments. And we did that by pushing up into Docker Hub and connecting into the cloud where you can then pull those images down. And then we use Docker Compose locally to spin up multiple containers at once. That's all I have for right now. We only really touched the surface. I know I've gone very fast, but I really, really appreciate your time. Thanks for joining us. And please do check out all the other DockerCon talks. There's a bunch of information. Thanks again. I really appreciate it.